Hello and welcome to CEN 4801. After looking at systems integration importance and system integration challenges, we need to address the strategies used to integrate system elements and the techniques used to define that strategy. Basically, how do we know which strategy will fit our integration or which technique? System integration and the integration of the different elements will be according to a predefined or selected strategy. The integration strategy selected will be based on the architecture of the system and the way it has been designed. A plan will be developed to describe the integration strategy and to define the minimum configuration of expected aggregates, the order of assembly of these aggregates in order to support efficient subsequent verification and validation actions, techniques to check or evaluate interfaces, and necessary capabilities in the integration environment to support the purpose of combining these elements. Since there are many strategies to select from, we can use one or more approach or technique to define which integration strategy might fit the company's system. The techniques of selecting the proper strategy will depend on the type of the system element or elements, the delivery time, order of delivery, and risks, constraints, and other custom factors that might be specific for that company's system or that system. Some of the techniques used to define integration strategy are global integration, integration with the stream, incremental integration, subset integration, top-down integration, bottom-up integration, and criterion-driven integration. Actually, the integration team could use any of these techniques individually or in combination with other techniques to achieve the integration process. We will go over each one of these techniques individually or separately. The integration strategy could be selected due to the global nature of the integration. So, global integration requires that all of the delivered implemented elements are assembled in one step. This technique, which is the global integration, will not require simulating the implemented elements not being available at the time of the implementation. Since all elements are assembled in one step, it will be hard to detect and localize the fault. Actually, some faults might be detected late in the process. This technique should be used for simple systems with few interactions and few implemented elements without technological um, risks. Another technique is the integration with the stream, where the delivered implemented elements are assembled as they become available. This technique will allow starting the integration as quickly as possible, but it will be complex to implement because of the necessity to simulate the implemented elements that's not yet available. It will be impossible to control the end of the end-to-end functional chains. Consequently, global tests are postponed very late in the schedule until all elements are available or are connected. This technique should be used for well-known and controlled systems without technological risks. A third technique is the incremental integration. In this technique, one or few elements are added to an already integrated increment of elements. Since the integration will be added incrementally, then a new fault is usually localized in the lately integrated elements or dependent of a faulty interface. This integration technique requires simulators for absent implemented elements. until they're present. Every time a new element or elements being added, the system must be tested and verified to make sure that the new configuration of the system is working as intended. This technique can be applied to any type of systems architecture. In the subsets integration technique, the elements are assembled by subsets, then subsets are assembled together. The subset is a group of elements or an aggregate, or could be called as functional chain integration. Integration through subsets is time saving due to parallel integration of subsets. Actually, the delivery of partial products will be possible at that point. This technique requires less means and fewer test cases than integration by increments, because we can do the test for the subsets. Subsets will be defined during the design phase. Such a technique can be applicable to architectures composed of subsystems. In a top-down integration technique, the elements or aggregates are integrated in their activation or utilization order. This approach will have a framework or skeleton to follow, and early detection of architectural faults is possible. Test data can be close to reality, and it's possible to be reused again. Many main branches or stubs, as we call it, need to be created, since it will be difficult to define the proper test on the lowest level of integration, which is called the leaf level. Mainly used in software systems integration. It starts from the implemented element of higher level, and the implemented elements of lower level are added when it reaches to the lowest level or the leaf level. In the bottom-up integration technique, elements or aggregates are integrated in the opposite order of their activation or utilization. It's easy to define the test cases that is needed for the system. In addition, faults can be early detected since they are localized and in the leaf implemented elements. This will actually reduce the number of simulators or the simulators to be used during the integration process. The problem that might occur that we need to redefine test cases for each step. Not to mention that some of the drivers of systems integration are difficult to define and realize. In this technique, elements of the lower levels are over tested and does not allow to quickly detect the architectural faults. Mainly used in software integration and many other systems. In this technique, which is the criterion-driven integration technique, we first integrate the most critical elements compared to a selected criteria, such as dependability, complexity, technological innovation, and other related criteria. And in this technique, it will allow us to test early and intensively for critical implemented elements. In addition, it will allow early verifications or verification of design choices. On the other hand, the data sets and test cases are difficult to define. To overcome the disadvantages of the different techniques, a mixed integration technique is selected as a trade-off, allowing for optimization of work and adaptation of the process to the system under development. The optimization tasks or takes into account the realization time of the implemented elements. Also, it takes accounts or account for their delivery schedule, the order they should be delivered, and their level of complexity and the technical risks. In addition, it will consider the availability of the assembly tools, cost, deadlines, and specific personal capability. Uh, Also, if there are any other constraints or requirements for the specific system, that will be also considered or included. Once we define the technique or mix of techniques used in the integration process, a plan can be developed to state or to include the optimized integration strategy, which is the order of the aggregates assembly using appropriate integration and using appropriate integration techniques. So in the plan, we have to state, which is our strategy, we have to state the order of the assembly, and we have to state what kind of techniques or mix of techniques are going to be used. In addition, in the plan, we need to include the verification and validation actions to be processed for the purpose of integration. We need to include the configurations of the aggregates to be assembled and verified. We need to include the integration means and a verification means that may include the assembly, validation, and verification tools and procedures. Integration tools or means can be obtained through buying these tools. We can purchase them, or developing in-house tools, or reuse existing ones that we used before, or subcontracting to a specialized contractor in the integration process. Usually, the acquisition of complete set of means is a mix of all the above methods. Since we are looking for a complete set of means, then some might be purchased, some might be developed in-house, some might be outsourced or subcontracted. So it's a mix of all. Once means implemented, we need to check the delivered integrated elements and the configuration and their conformance and their compatibility of interfaces, and to ensure the presence of the mandatory documentation that will come with it to explain exactly how that was done or what needs to be done in case that we need some kind of a maintenance or follow-up with the system. To assemble the integrated elements, we need to gather the implemented elements to be assembled. Then the integration means should be obtained, and also we need to obtain the verification means. We need to connect the implemented elements with each other to constitute aggregates in the order prescribed by the integration plan and in assembly procedures using the assembly tools. We need to add or connect the verification and validation tools to the aggregates as predefined. And we need to carry out the final touch or touch-ups and operations to make sure that the system is working as intended. To verify the aggregates, we need to check the aggregates or the aggregate to make sure that they are correctly assembled according to the established procedures. We need to perform the verification process that uses verification and validation procedures and check the aggregate shows the right design properties or specified requirements. We need also to record integration results reports and potential issues or issue reports that will establish a change request if needed. Any changes that will be as a result of the integration has to be documented, and then a change order will be established, and then a request will be submitted. And then if we have other steps that can be added to that integration as needed. So what are we checking during the integration? The integration plan implementation, according to, we are making sure that everything is going according to plan. The expected assembly order, which is the integration strategy, to be realistic and feasible. We need to make sure that no system element and physical interface set out in the system design document is forgotten. We need to make sure that every interface and interaction between implemented elements is verified. We need to make sure that the assembly procedure and assembly tools are available and validated prior to beginning the assembly. And we need to make sure that the verification and validation procedures and tools are available and validated prior to beginning the verification. In addition, we need to create reports and record everything that's been done during the integration. This slide shows some examples of systems, their elements, some of the tools that can be used in different areas, and the recommended integration techniques. The suggested tools may differ from one organization to another, but this is like a general framework on what can be used and what kind of elements are available. So you can see that we have some elements. We have the physical interface, we have the assembly tools, verification tools, validation tools, and then we have the recommended integration techniques, which is the most important thing. So for example, when we say product systems such as hardware parts like machines, electronics, electrical parts, or plastic or chemical, then we can use the top-down integration technique or bottom-up integration technique based on that system. If we are talking about a service system, which is like procedures, processes, databases, then we can use subsets of integration technique to integrate those elements with each other. If we are talking about enterprise system, which is corporate, direction, division, department, project, technical, teams, leader, like we said, those are the elements, which is like the people, the procedural data, the hardware, the software, all these components need to be put together. And we can use with enterprise resource planning or with enterprise systems, actually, we are dealing with nation and global interaction. So in that case, we need to include what we call the global integration technique, and maybe it can be done incrementally, since we are going to use many elements, many complex elements, and put them together to work in harmony. So that will be all for this session. If you have any questions or concerns, feel free to email, call, Skype, or come in person to my office, and I will be more than glad to assist. Thank you and have a great day.